Hey everyone, I am Shreyanstas and you're watching RoboStruct. Now, if you look behind me, what do you see? I know you must have many questions in your mind. What is this? Well, exactly, this is the Milky Way galaxy. But why is it blue? Don't worry about it. I'm gonna explain this later in this video in perfectly detailed manner. Before we start our video, make sure to like this video and consider subscribing to our channel and do share our content. And now, let's begin the video. For the first time, the IceCube Neutrino Observatory has created an image of the Milky Way galaxy using neutrinos, minuscule elusive particles of the cosmos. But first, let's understand what are neutrinos briefly. Neutrinos are teeny tiny, nearly massless particles that travel at near light speeds, born from violent astrophysical events like exploding stars and gamma ray bursts. They are fantastically abundant in the universe and can move as easily through lead as we move through air. This revolutionary data comes from an international collaboration of over 350 scientists and is backed by the National Science Foundation in 14 additional countries. The groundbreaking observatory is located at the South Pole and employs over 5,000 light sensors to detect high energy neutrinos that originate from both our galaxy and beyond. Our Milky Way galaxy is an awe inspiring feature of the night sky, viewable with the naked eye as a horizon to horizon hazy band of stars. Now, for the first time, the IceCube Neutrino Observatory has produced an image of the Milky Way using neutrinos, tiny ghost-like astronomical messengers. In an article published on June 30 in the journal Science, the IceCube Collaboration, an international group of over 350 scientists presents evidence of high-energy neutrino emission from the Milky Way galaxy. The high-energy neutrinos with energies millions to billions of times higher than those produced by fusion reactions that power stars were detected by the IceCube Neutrino Observatory, a gigaton detector operating the South Amsterdam Scott South Pole Station. It was built and is operated with National Science Foundation, funding and additional support from the 14 countries that host institutional members of the IceCube collaboration. Well, what's intriguing is that, unlike the case for light of any wavelength, in neutrinos, the universe outshines the nearby sources in our own galaxy, says Francis Halzen, professor of physics at the University of Wisconsin, Madison, and principal investigator of IceCube. The interaction between cosmic rays, high energy protons, and heavier nuclei also produced in our galaxy, and galactic gas and dust inevitably produce both gamma rays and neutrinos. Given the observation of gamma rays from the galactic plane, the Milky Way was expected to be a source of a high energy neutrinos. A neutrino counterpart has now been measured, thus confirming what we know about our galaxy and cosmic ray sources, says Steve Scalfani, a physics PhD student at Drexel University, IceCube member, and co-lead analyzer. The search focused on the southern sky, where the bulk of neutrino emission from the galactic plane is expected near the center of our galaxy. However, until now, the background of muons and neutrinos produced by cosmic rays interaction with the Earth's atmosphere posed significant challenges. To overcome them, IceCube collaborators at Drexel University developed analysis that select for cascade events or neutrino interactions in the ice that result in roughly spherical showers of light. Because the deposited energy from cascade event starts within the instrumented volume, contamination of atmospheric muons and neutrinos is reduced. Ultimately, the higher purity of the cascade in events gave a better sensitivity to astrophysical neutrinos from the southern sky. The dataset used in study included 60,000 neutrinos spanning 10 years of IceCube data, 30 times as many events as the selection used in a previous analysis of the galactic plane using cascade events. These neutrinos were compared to previously published prediction maps of location in the sky where the galaxy was expected to shine in neutrinos. Observing our own galaxy for the first time using particles instead of light is a huge step, says Naoko Kurahashi Nilsson, professor of physics at Drexel University, IceCube member, and Sculfani's advisor. As neutrinos astronomy evolves, we will get a new lens with which to observe the universe. That's all for today, folks. I hope you like this. Subscribe to the channel and like this video. Press the bell icon and stay tuned for more upcoming videos.